Hello folks, we come to the part 6 video of this exercise 1.4, and here before we start the video itself, just one small correction to the question number 6. Part number 5, they had asked us the invertible elements. I had told you that none of the elements in the set of natural numbers is invertible. It's true for all elements other than 1. 1 is invertible. The question was specifically saying which number is invertible. So it is 1 which is invertible, or all other elements are not invertible in the set n. So that's how we have to restate it. So that small correction, and then we are coming back to the question number 7. In the question number 7, they give us a set 1 to 3, made up of elements 1, 2, 3, 4, 5, and they say that there is an operation star which is defined as LCM between A and B. So to check if it's binary, means checking binary means we operate it between elements and check if the elements that forms, whether they are belonging to the same set or not. Say it's enough if you give one example. Yeah? We are done with that if you give one example, or you make a composition table. It's your wish. At one site, if you can know what is the element, that way you can do, or maybe you can make a composition table. It's all your wish. So maybe we'll just do a composition table, because we will also get used to this idea of what this LCM and all that cooperation table and all that is all about. Depends on the mark. If it is just for 1 mark, you just give one example and just get off with it. But suppose it does come for a higher mark, then we'll do all this and we'll find out exactly how. Yeah, we'll quickly have it. 1, 2, 3, 4 and 5 are the elements. So one, 2, 3, 4 and 5. So 1, 2, 3, 4 and 5. LCM between 1 and 1 it's 1. Between 2 and 1 it's 2. 3 and 1 3. 4 and 1 it's 3. 5 and 1 it's 5. Between 1 and 2 it is 2. 2 and 2 it is 2. 3 and 2 it is 6. 4 and 2 it's 4. 5 and 2 it is 10. Then 1 and 3 it is 3. 2 and 3 it is 6. 3 and 3 it is 3. 4 and 3 it is 12. 5 and 3 it is 15. See, generally when they co-prime, it is just the product. Okay, and otherwise if there is common factor, means we have our age old technique, like 2 and 4 for example. Then 2 1s are 2, 2 2s are 4, then 2 1 1. So 2 2s are 4. That's how we got between 2 and 4. 4 and 2 we got it as 4. Then between 4 and 1 it's 4. Then 2 and 4 it will be 4, 3 and 4 it will be 12 because it's co-prime, 4 and 4 it will be 4, 5 and 4 because it's co-prime is 20, then between 1 and 5 it's 5, between 5 and 2 it's 10, between 5 and 3 it's 15, and between 5 and 4 because they're co-prime it's 20, 5 and 5 it's 5. So it's very clear from the composition table itself that it's not binary, because there are so many elements which are coming out of the set. Yeah, your set is having only the elements 1, 2, 3, 4, 5, and look at so many elements which are outside. See, 6 is outside, then you have 12 which is outside, 10 which is outside, 15 which is outside, 12 which is outside, 20 which is outside. See, so many elements are out of the set. Okay, so you can say that you can say like that in the composition table we can see, or in the operation table we can see so many elements are not belonging to the given set. Or you can actually state and say that maybe here 2 star 3 is 6, which doesn't belong to the given set, like that. Or you can say that the operation table has many elements not belonging to the given set. Yeah, so you can reason it the way you want, not belonging to the given set. Yeah, composition table also sometimes we call it as composition table, sometimes we call it as operation table and all that, whatever it is. Okay, then we come to this next question where it is A star B defined as HCF between A and B. That was LCM, here it is HCF. Now the question says whether you have to check whether it is commutative, whether it is associative, and whether the identity exists. Now we've checked number of times, isn't it? Commutative, associative, but still for routine we will check commutativity. Consider A star B. So that is HCF between A and B, and B star A Again, that is HCF between B and A. Therefore, A star B equal to B star A, because HCF, whether you take A and B or B and A, it's going to be the same value. So that way we have star is commutative. Same way we'll look out for associated. Consider A star B star C. A star B is the HCF between A and B. Star C means it is HCF between first, HCF between A and B, then C naught. All that is not required. It's as good as taking the HCF of all the three values, right? All that is, it will amount to the same thing. And A star B star C, same way, it is A star HCF between B and C, and technically this is HCF between A and HCF between B and C, but all that is not required. It is as good as saying HCF between A, B and C. Like that, you have them equal, A star B star C to be equal to A star B star C. Like that, star is associated. Okay, then whether the identity is existing or not. So for that, let's check whether the identity is existing. Consider A star E to be equal to E. That means HCF between A and E will become A. What is that E? So when you see HCF becoming the same number, you have a number A, you have a number E, you get, for example, 5. 5 and which number will give you the number 5 itself as a highest common factor? Whether it is ever possible? It's not possible, right? It's not possible for us to get the value E. See, whenever you have a number, HCF means a highest common factor, right? So if you have to get that same number back, it should be the number that E, that number should be either the number A itself, or it should be a multiple of A. That means every time A is changing, E will also change. We are not looking out for such identity. Identity elements is universal. It will not change with the value of A, right? So we are not able to find. So E could be, we no need to write, but we'll write, it could be A or multiple of A. Only then the highest common factor can become A. But E cannot depend on A. Therefore, identity does not exist. It should be universal, something like 0 or something like 1, which doesn't change from element to element. Now here it is going to change from element to element, so that is why such a value of identity does not exist. Of course, it's commutative and associative. So that's all about this video. We have this part, in fact, with more problems. I think we should be coming in the next video. That's all. Thank you.